Now let's look at the next topic. We want to implement some simple cache, but why? Let's look at some numbers. Let's first see how much time it takes to use our function. For that we can type, say, we need some kind of a loop over the following thing. Measure command, which will measure our get Azure table data thing. And then we can save this into a variable. Let's wait for some time until it completes. It shouldn't take too much. Okay, now what we can look at, we need to look at contents of this variable. It's an array, so we will just take the first element to see what's there. Yeah, okay, so this is basically um, an object that represents our measurements. Let's do some calculations. Let's do some magic. So we can say, oops, total milliseconds, and then we can say measure object, and we want to see average and sum by this total milliseconds. So what we have here is that in average we have 1.5 seconds to execute. Let's look just for test. Let's look at another example. Let's change this to get Azure RM locations. Okay, this may take some time. I'll pause the video so we don't need to wait. Okay, this is done. Let's see what we have. And here we've got 3.5 seconds to execute a single run. This means that when our data source sits in the cloud, it takes time to query data and return it back. Sometimes it's acceptable, but in our case, we want to use this data right in the console, which means that each time we issue this query from the console in interactive mode, so to speak, we will wait more than a second to get a result. And our data set is really small. If it was bigger, we would need to wait even more. Not very good thing, I should say. So to overcome this issue, I'd like to introduce a simple cache for our CMDB data. For that, we will use PowerShell classes and something called singleton pattern. In simple terms, this is the way to restrict the instantiation of a class to one object. In more simple terms, this means that we want to have only one instance of something across our code, and even more, we want to enforce this. We want to make sure that this object will always be only one. Okay, let's create our class. For that, we're going to create cache.ps1 file where we're going to put our class and put some code here. So first of all, in this class, we have a member called cache, which obviously holds our cache. The next thing is a static member instance. And then we have a hidden constructor. Constructor basically is a function that gets executed at the moment of creation of a class. Our instance member is initialized by the reference to the instance of a class. So when first called, this member will be initialized right away, and during initialization, constructor will be called, which will in turn initialize our cache with our data. Another trick to mention here is DB, member of our cache. Basically, what happens is it is possible to dynamically add keys into a hash table. So we have just an empty hash table stored inside of cache variable, and our constructor will add a DB key into this hash table and will initialize this key value pair with our data. This trick will allow us to add more data into our cache if we need it later. Before we continue our implementation, let's look at the whiteboard once again. First of all, what we have so far is we have this commandlet, which represents our CMDB interface or CMDB connector. We have cache, and what's left is interface commandlet. This interface commandlet will have a standard well-defined interface or standard well-defined set of parameters, and all of the interfaces for all of other CMDBs we may have will have the same set of parameters. So let's switch to it. To implement this, we are going to create another function and call it get Azure CMDB data. This function will have a standard interface, which will look something like this. It's going to be two switch parameters. First one is BU, and second one is depth for department. So when either one is provided, this function will return either BUs or departments. So how to do this? We need to check if the switch is set. Then we do something. Let's do the same for department switch. Something. And next thing, if no parameters were provided, we would like to return everything. So how can we do this? We want to use our cache. Let's instantiate this. So for that, we're going to say CMDB, how it's called. Let's pick it from here. CMDB cache instance cache DB. So we're just trying to touch our variable, our DB variable inside of a cache. So at this moment, what's going to happen is the system will try to reach out to our instance member, which will in turn call this new function, which will in turn call our constructor, which will in turn initialize our cache with DB. And this string will basically return its contents. So there are a lot of calls, but this is going to happen only once. So what we're going to do for this case, we're going to do something like this. We need to take the whole thing and then filter it. by partition key. It's gonna be like that. And here we're going to put the same, but with depth. Now, what we need to add is we need to add return key, so only one switch works at a time. Great. Looks like it, so let's try everything. We have loaded this class. Now we need to load everything else. Clean this up and call this function. Yep, now it works. Let's call it with more than with BU parameters, so to speak. So we have returned only BU components, depths, departments without any parameters. We have departments and BUs. So everything works. So we can say that we have implemented everything in this replaceable part. Okay, let's make some measurements of our new functions in the PowerShell console and see how it works. First of all, we need to import our module, verbose. So we see that we've got few more functions. So let's try to do this. Let's try to do our loop over the measure object or measure command calls, trying to call our new function, and let's store everything into a variable. Let's wait for a minute. Good. So let's see what we have as the first parameter. So it takes 2 seconds, 2.5. Let's see what we've got here. It's just less than a second, 0.4. First, second, third, and so on. So if we try to look at total milliseconds, so the average is about 250, 260 milliseconds. So it's pretty good win in our case with the cache.